Good evening, and once again welcome to my YouTube channel, Maths with Ease by Mr. Kamotho. And in this video I'm just going to respond to a question on graph 6 exam practice question number 3, whereby we are expected to plot the graph and answer the questions that follow. And the question says the petrol consumption, or Y kilometers per liter, of a car is related to the speed x kilometers per hour by the formula y is equals to 70 minus x over 3 minus 2400 over x. The petrol consumption y kilometers per hour is related to the speed in this kind of a relationship where y is the petrol consumption. That means y kilometers per liter, and x is actually the speed in kilometers per hour. And the first question is copy and complete the table of values. Y is equals to 70 over x over 3 minus x over 3 minus 2400 over x. And you're just supposed to take the value of x starting from 60, 70, 80, all the way to 130. And for us to plot this graph, we need to tabulate this information. For example, when x is 60, you substitute 60 in the equation given. For example, x over 3 is minus 60 over 3, which is minus 2. And the column of 70 is represented, the row of 70 is represented, minus x over 3 is represented, and negative 2400 over 3 is also represented. For example, let me just explain this column. When x is 60, 70 is a constant because it is already in the question. Minus x over 3 is minus 60 over 3 because x is 60, which gives us negative 20. And 2400 over x, which is 2400 over 60, which is negative 40 because there's a negative there. And then the value of y is the sum of all these three rows. 70 minus 20 minus 40. 70 minus 60 is actually 10. And it continues that way for all values of x. And that's how I have come up with these values you can see already filled. For example, when x is 60, y is 10. When x is 17, y is 12.5. When x is 80, y is 13.3. When x is 90, y is again 13.3. And so on until when x is 130, y is 8.2. That is part A of the question. Part B of the question is saying, draw the graph of y is equals to 70 minus x over 3 minus 2400 over x for values of x between 60 all the way to 130. And this is just what I've done, because now I was picking values from the graph, and all those values are actually now being plotted in the graph, and this is just what I came up with. This is what I came up with. So you will see the graph here. There comes the graph. And of course, let me just interpret the graph a little bit. The y-axis is representing the number of kilometers per liter, the number of a car could travel per liter. That is why we have y kilometers per liter. And the x-axis is simply talking about the speed of the car. The x-axis is talking about the speed of the car in, of course, kilometers. The speed of the car in kilometers. That is part B for you. Now, that is part B, and of course we have been able to plot the graph that way. For example, when x is 60, note that 60 is not at the origin. There's a broken line here to show that we are coming from far, but because we don't need the values of x below 60, we are just starting at this particular point. When x is 60, y is 10. When x is 70, y is 12.4, as you can see there. When x is 80, y is 13.3. 90, 13.3. 112.7, 110, 11.6, 120. We have y being equals to 10, as you can see, when x is 120 kilometers per hour. And when x is 130 kilometers per hour, then the consumption 8.2 kilometers per liter. That is part B for you. Part C, let us now answer the question part C. To use your graph, part C is having this question. We have now to answer this question. Use your graph to estimate the petrol consumption at 115 kilometers. Use your graph to estimate the petrol consumption at 115 kilometers per hour. What I did and what you should do, you identify 115 kilometers, which I have identified here. You draw a line with a ruler, dotted line. This is 115 kilometers per hour. You draw a line that meets the graph, and at the point whereby the line meets the graph, you draw a horizontal line now to read the consumption, which is 10.8, slightly above 10.5, which is exactly or around 10.8 kilometers per liter. Now this is 10.8, don't be 10.80 kilometers per liter. 10.80 kilometers per liter. That is the consumption when the car is traveling at 115 kilometers per hour. And part D of the question, use your graph to estimate the most economical speed at which to travel to conserve petrol. Let me explain this a little bit. The most economical speed is the speed whereby the car uses, the car travels the highest number of kilometers per liter, or in 1 liter of petrol. With 1 liter of petrol, the car travels the highest number of kilometers. So in this case, we are trying to identify the highest point on the y-axis, which is talking about y kilometers per liter. And of course, we identify the tangent of the circle at the top there. We draw a line to actually meet the curve at the topmost, at the turning point. And at that particular point, this is already almost 13.3 kilometers. We can talk about 13.4 kilometers because this is 13.3 and this is 13.3. And the speed responsible for that conservation is around 85 kilometers per hour. So when the car is traveling at 85 kilometers per hour, the consumption of petrol is, it travels for 13.4 kilometers in 1 liter, or with 1 liter of petrol. And that is the point whereby, or the highest, that is the most economical speed of 85 kilometers per hour, because the car only travel 13.4 kilometers in 1 liter only. That is the end of the question. So follow me in a different video and let's see you later. Thank you.